All right. Well, I hope you had a nice weekend, and we'll get started here. Uh-oh. Seconds. I hope this is working correctly. All right. Um, so today we'll look at. It says a few more OOP methods and some Pythonic features. So there's a few more things that I want to kind of demonstrate regarding objects in Python, just because there's, I don't know, I think there's so much stuff we can do, right? So especially when you implement these double under dunder methods, it kind of enables a lot of other operators and functions to work. So far we've created this card class, which we use to kind of keep track of, or we use to create cards from a deck of cards, and we have and basically it consists of two numbers, one for the suit and one for the rank. Okay, and that's covered in the init method, and then we've defined a few dunder methods. We have string, which is the string representation of the card, and then we have less than and equal to be able to compare cards. And the way we have it is we have all of the suits are more important than the ranks, so we're going to have all of the spades rank higher than, say, all of the hearts, which rank higher than, I think, diamonds and then clubs. And so the two of spades is a higher rank than, say, the ace of hearts. Okay, and so I think this is what we have so far: suit names, clubs, diamonds, hearts, spades, and we enter a suit 0, 1, 2, or 3, and then for the rank it's going to be 1 through 13, and then we'll say something like 3 of hearts or something, and then for comparison we have the less than. We can compare ourselves with another card, this card with another card, and then test for equality. Basically, we just create tuples out of these things, and we do tuple comparison. We've also, I feel like my ears are playing tricks on me. I don't know what's going on. Okay, we've also defined a deck class, and the deck class contains cards. And we've also created a hand which inherits from deck. But basically, when we first create a deck, there's going to be 52 cards. It's going to iterate. It's going to kind of just iterate through all 4 suits, and within each suit, all 13 ranks. It's going to create all of these cards. And then we've created a few methods. We have pop card, add a card, shuffle the cards. We have we can do sort, which is enabled because we have this less than function defined inside the cards, so we can use sort for comparison. And then we have move cards, which will move cards from one deck to another, which is useful because we've created the hand object, which inherits from deck, and we can, when we create a hand, it's going to inherit all of these same methods. Okay, and then shuffle requires us to use random, and that's fine. Okay, so this is our deck class. To initialize the deck, we iterate through all the suits, and within each suit, we iterate through all of the ranks, and we create cards of basically all of the suits and ranks. And then we have the string representation of itself, which is just going to take the string representation of each card, append them to kind of a list, and then we print out the list by joining them using the new line character. Pop will take the again, self.cards is a list of all of the cards. We'll pop the last item from the card. We can append a card to that list. We can shuffle self.cards. We can also sort them, and we can move cards. hand inherits from deck, and really the only thing is that it also comes with a label. All right, and so here I'm initializing, creating a new deck. I'm going to move 5 cards from the deck. We're popping the last 5 cards from the deck and moving them into the hand. And so the hand now has the last 5 cards, the 5 highest, I guess, cards of the, because the way we have it is ace comes before 2, and so we have it like this. Okay, so one issue with so far I'd say everything is working pretty well. One issue that we run into is when we create a card and we ask, what does this card look like? When we print out card 1, we get, this is what Python prints out. It says this is basically a card class object, an object of class capital card located at this location in memory, which is fine. We have this print method, which gives us kind of a more user-friendly output. Okay, so we say, oh, okay, card 1 is the 2 of clubs. We can say, what's card 2? And it's card 3, 11, and this is the jack of spades. So this thing is technically the card representation at this location in memory, and that's true. It's just this is difficult for us to read. And so, and then when you print out, what is the hand? Okay, so right now our hand is, if we've moved 5 cards from the deck into the hand, and let's see, is this a new hand? I don't know if it, so we have these 5 cards. I think these are 5 new cards from the deck, so probably the 4 through 8 of spades or something. But again, this is completely unintelligible when you see it printed out like this. This is technically what it is. It's a list of these cards, but it's difficult for us to make any sense of it. So there is another Dunder method called repr, okay? Which basically means the representation of the card object, right? And this is kind of like, so you have the string representation. So when we define the card method way back here, this is the string representation. And so when we print out the card, it's going to say 2 of hearts, 3 of spades, things like that. Okay. The representation. Okay. What it should be the Python command that is used to create this object. Okay. So if you want to create the jack of spades, the way we created the jack of spades is we called capital C card 3, 11. And when we do this, card 2 is going to become the jack of spades. Okay? And thus, the official representation of the object is going to be card 3, 11. Right? So the string representation is going to say, quote, jack of spades. Right? It's a string. Here, it's going to be the kind of the command that we use to create the jack of spades. Right? And so here I've got these two things. Okay, this one will return jack of spades, and we're going to find self.rank and pull the appropriate rank name, self.suit, and pull the appropriate suit name. The representation is a string here, but it's really just going to just use the integers. Okay. Formatted as strings. Okay, so we're going to have format self.suit and self.rank as strings, and it's going to say card 3, 11 or whatever it is that we're doing here. And so now that we have this representation here, this is what's going to output when we ask what is the card. So if you recall, we created card 2, which is a jack of spades, okay? And when we this was created under the old card definition before we had this dunder representation method. And so this is how it used to appear. This is how it appears. It's just this card object at this address in memory. And if you want to know what it is, you can call Jack of Spades. Here I'm going to create a new card. Card 3, 11 is going to be card 3. And so when I ask what is card 3, card 3 comes back as card 3, 11. This is now using the representation method. Okay? And I didn't lose the string method, so if I say print card 3, it's going to find the string representation, and it's going to say Jack of Spades, which is what we want. And we can test, is card 3, is it equal to card 2? This is a test for equality, not to ask if it's the same object. Okay? There are two different objects. One is at this location in memory, and this card 3, 11 is a Jack of Spades at a different location in memory. So if I say, if I asked is going to come back and say false. They're not the same object, but are they equal to each other? These two cards are equal to each other. They're both Jack of Spades. It's just that card 3, under the new definition, has a much more, I think, easier to understand representation. Even if it's not as user-friendly as the string representation, Jack of Spades, but it's unambiguous what the suit and rank is and how it's stored and represented inside inside Python. So this is the representation, and now this, if we say, okay, we're gonna create a deck class, okay, which uses the same thing, and hand which inherits from deck. Okay. Now when I say print hand, okay, so we've moved. So I've created a new deck. I've created a new hand. We're going to create King of Spades, or move 5 cards from the deck to the hand. So we have King of Spades, Queen of Spades. This is the string representation of the hand. And then if I do hand.cards, rather than a list of all these dunder main.card at this location in memory, now I have basically a list of the card representations here. Okay, the representation: card 3, 13, card 3, 12, card 3, 11, card 3, 10, card 3, 9. Okay, versus a few slides back. Versus this, what this looks like, okay, which is not fun. This is a little bit easier to read, okay? Or I'd say a lot easier to read. It's not as easy to read as just the plain English, but certainly, this is kind of a cross between like code output and something that's intelligible. Okay. Oh, let me give you your first view quiz answer. It is B. B as in bear. B as in bear is your first view quiz answer. Okay, what if we wanted to ask how many cards are in the deck or the hand, or what if we wanted to access the list of cards in the hand or deck directly? Okay, so currently our hand and our deck class objects, they contain other things, but they don't act like containers yet. Okay, and what I mean by that is, if I say here, what does my hand look like? Okay, the hand is just this object in memory, and there's 5 cards in the hand. Okay, but Python doesn't know that. Okay, and so if I ask what is the length of hand, Python comes back and says hand has no method length. Okay, and And I think it makes sense to ask a question like, how many cards do you have in your hand, right? What is the length of hand? That's a question that makes sense, but we haven't defined that method, okay? We could ask, okay, what are the variables in hand? And we see, okay, there's the cards inside hand. There's kind of two variables in there. We have cards and label. Label is new hand, and cards is a list. And it's a list of 5 cards, okay? And now that we have the Python representation, the dunder repr to show what it looks like. This is what it looks like. So we could say, hey, what's the length of hand.cards? Hand.cards is this list, and we get back 5, okay? But it would be nice if we didn't have to do length hand.cards. We could just do length of hand. So all we have to do is there is a dunder method for double under length, okay? So we could do double under length, and this is a special method. And here we're just going to say, if somebody asks, what's the length of a hand, we're going to give it back the length of self.cards. Okay. Okay, and so that's going to go in right here. And everything else is fine. And so here, when I create a new deck, I can ask, what is the length of the deck? And it comes back and it says there's 52 cards in the deck. I'm going to move 5 cards from the deck to the hand. The length of the hand is 5. And if I ask, what's the length of the deck now, it says 47. Okay, so I think that's what we expect it to do. Okay, so that's the length method. All right. Now, what if I wanted to kind of subset, and I wanted to just say, hey, what are the first 5 cards? Like, take a peek at the deck and just say, what are the first 5 cards in the deck? Now, a list, if the deck were a list, and it's kind of a list, but it's not exactly a list, right? It's a list containing 5 card objects. A list would be able to do this. We would be slicing the list, and right now it comes back and it says you can't slice the deck, okay? Because this hasn't been defined. And if we wanted to iterate through the deck, right? If we tried to do something like this for each card in the deck, print out the card, and this also, it says, you can't do that. Okay, the deck is not iterable. But conceptually, it feels like we should be able to iterate through a deck. We should be able to subset the deck and pull things out. Okay, and then and then this one just says, what if we want to see the hand sorted without changing the hand? So we do have a method called sort inside the, if I go back. So we do have this method .sort, but it employs the list method, which actually modifies the list in place. And what if, if we didn't want that, and we want to call, say, sorted, which just returns the thing back. Again, it gives us hand is not iterable, which is a little bit, it feels a little bit strange. Okay, it says deck object is not iterable, and then when we're asking for it to be sorted, it comes back and it says it's not iterable. It doesn't say something like there's no sort method or something like that. It gives us this thing, which feels a little bit strange. Okay, these things are powered by a dunder method called getItem. GetItem, and once you define double under getItem, okay, then the object that you've defined will start to act like containers, like lists, like dictionaries, like tuples and things like that, which is pretty cool. So this is what we're gonna, how it's gonna work is it's gonna be getItem self comma key, and basically you tell Python how to get a particular key object. Okay, so in our case, when you call get item, it's expecting some kind of value to be passed to it. And it could be a positional argument, like the way you'd subset a list. You can say, I want the index 4 item in a list. Or it could be something like a dictionary, where you say, I want the value associated with key A, or something like that. Okay, so here in our case, we're expecting to get kind of positional values, and so again, this is just an arbitrary keyword. We're calling it position because that makes sense to me, but it's just an arbitrary keyword. Arbitrary keyword. It could be whatever. But here we're going to say, okay, whatever key gets passed, whatever value that comes in here, we're going to treat it like a position, and we're going to basically just pull out the object at this index location. Okay, and this is because self.cards is a list. It's going to be a position argument. Okay, if self.cards were, say, a dictionary, this would be a dictionary key. So all we're going to say is, okay, what dunder get item is going to return the card object inside self.cards at that position. And of course you could imagine more complicated ways to get an item if you had a more complicated class or object class defined, but we don't need to make it any more complicated. So here we are. We're going to do dunder get item. Okay, and so we're just increasing the definition of our deck class. And I think we can understand all of these methods, right? So that the goal is for you to be able to read someone else's class definition and at least kind of follow what's happening here. Okay, so here we go. We're going to create a new deck with our new definition. If I print out the deck, it's going to list off all 52 cards. Now, look at this. I can slice the deck. Okay. Now that I've called get item, I can perform slicing, and I can say, give me the first 8 cards in the deck, and it comes back with a card representation of this, right? Or the Python representation. This is card 01, card 02, card 03, and we can see, okay, that's going to correspond to ace of clubs, 2 of clubs, 3 of clubs, so on and so forth. If we wanted to, we can also perform iteration over this over the deck object. Okay, so now I can say for item in deck 0 through 8, print the item. Okay, so we can take this thing and we can iterate over it, right? Whereas before we couldn't iterate over it, we couldn't slice and things like that. And basically get item allows it to act like a container, which it kind of is, or it is. It contains other. It contains card class objects inside of it, and so this is what we have here. Okay, so it says for item in deck 0 through 8, print the item, and this works here. All right. Okay, and so with get item implemented, all of the kind of the slicing rules all work. So here, if you remember, the colon notation for slicing, here I'm going to say start at the index 12 card, and never basically go to the end. Okay, so colon, so usually it's the start object, the ending object. The ending object is empty, and then here after the second colon is the step size. So we're going to say start at the index 12 object and take step sizes of 13. So what does this correspond to? It's going to correspond to card 013, 113, 213, 313. And if we were to print each of these things, these are going to be all the kings in the deck. King of clubs, king of diamonds, hearts, and spades. Okay. Here we'll have a hand inherit from the deck, and I can call shuffle the deck, and we'll move 5 cards from the deck to the hand. And now that I have, and so it's a little bit strange, but when you have get item, it sorted now works, okay? Because sorted actually works by using the get item dunder method. It looks at the entire thing and it compares all the objects, and it basically gets the values based on these comparisons. So it's not going to actually sort the hand. So here it gives us the cards in sorted order, where clubs comes last, then all of the hearts in order from least to greatest, and then the spades. Whereas the order of the cards in hand itself remains unchanged, right? Sorted gives you back a sorted look without actually modifying the values inside the list itself. And so we can see here, these things technically aren't in order. Jack of spades, or Jack of hearts, was at the top, whereas, if we were to sort them, it would come, I guess, fourth. I'm going to get through all of my slides a little bit quick today. Let me go ahead and give you your second view quiz answer. Today's second view quiz answer is the letter C. C as in cat. Wait, I just said C, right? Okay, that's correct. C as in cat is your second answer. Okay, so that's what happens when you implement get item, and then you have set item. Set item allows us to basically use assignment. Okay. So in our case, we would use set item to assign a card object to a particular position in the list. So when you call set item, it's going to accept kind of two arguments. One is going to be the key. Basically, in our case, it's acting like a list, so we're going to give it the position. The key is going to be the position and the value, and the value we expect to be a card object. So in our case, we're going to do self.cards, and we're going to say take whatever key is, put it in this position, assign the value, which is going to be put the card there. And so you have a method, or you have a function like random.shuffle, and this works by using the set item method to basically rearrange the order of objects inside a container. Now we already have a shuffle method defined inside deck, but by using this, that method becomes unnecessary. Okay, so we don't actually need to use deck.shuffle, and we could just use the shuffle function, which is what we would use for just list objects. So list objects don't have a .shuffle method, but you would just use random.shuffle, and you would give it container objects like lists. So here I've commented out the method shuffle. It's no longer necessary. And here I've just defined a method called set item. Set item here. All right, so once again, here is a new deck, and just printing out the first 10 cards in the deck. This is what we see. All right, now I can just call random.shuffle. Random.shuffle on the deck. Okay. Before we would call deck.shuffle, but now we're doing this. And if I look at the first 10 cards from the deck after I've shuffled it, now we can see we have this 9 of diamonds, 5 of spades, ace of clubs, so on and so forth. And that's that. Okay, so there's a bunch of kind of bunch of these Pythonic methods. Okay, let me and this is all kind of, I think I've got no. All right, sorry. All right. The Python object model. So there's quite a few more references here. In the so this is, it says emulating container types, but basically this is a very long piece of documentation. But it's quite good. If thankfully Python is just super well documented in my opinion. So the data model is basically going to go through all of the different dunder methods that you can implement when creating your own class, and it will run through how this is going to work when you do this, right? So so you have dunder init, dunder delete. So we didn't cover this, but if you needed to say, hey, remove a card from a thing, things like that, you can implement that. You have the representation, the string. You have other things. Okay, so we've gone over several of these things. The less than, and equal, and you could do also greater than or equal to and stuff like that. There's quite a few here. Okay, that you can kind of read through and see how the Python object model or data model works. But we'll stop there. Okay, let's go over some Python features. So these are now stepping away from object-oriented programming and just talking about some other features that Python has implemented, which we can use to kind of make our code quote-unquote Pythonic. I don't know if you've heard of that, but you'll hear people talk about code being Pythonic, and basically, Python is written so that you, the programmer, can kind of do exactly what you need without having to worry too much about other stuff. And there's kind of these nice, almost, idiomatic expressions that take advantage of a lot of these, features that Python has that, would generally require a bit more legwork to create in other languages. So, so some of these are just kind of nice. So one of this is the conditional expression. Okay. So a conditional expression will just check a condition and run the associated code, kind of like an if statement. But let me just show you how an example of how this works. Okay, so we want to say find the natural log of a number, and you can't calculate logs of basically anything less than 0. So but we're going to just say if it's less than or equal to 0, we want it to return nan rather than an error. So here, if I do x is equal to -3, right now I just have a if else statement, right? So we can do if x is greater than 0, y is equal to the log. Okay, otherwise y will be a nan. Okay, and right now if I say give me the log of -3, we get nan. Okay, you can do this in a single line, basically. Okay, so it's basically implementing this if-else statement within a line here. Okay, so here we're going to say y is equal to math.log, and then and basically kind of after the fact. So we're going to just say, let it be math.log if x is greater than 0, okay? And then otherwise, assign it to float nan, all right? Now, it's arguable whether this is easier to read or this is easier to read, right? It's, you know, we could debate about it, but if you're kind of if you're used to seeing code like this in Python, this makes your code a lot more concise, and I don't think it takes away from the readability, okay? You know, when you're thinking of code, we're probably accustomed to thinking of if this, do this, else do this, and you know, return this kind of thing. And we're kind of accustomed to thinking about that. But you can basically write the same exact expression just in a single line, and that way you can also kind of create a whole bunch of things without having to have these chunks of that take up, you know, rather than 4 lines of code where you have an if and an else on there, each separate lines, you can kind of do several of these things just one line at a time. So things like, you know, taking the log and the square root and things where, you know, it doesn't work. You know, you just need a simple condition so it doesn't break. You can do that, right? So this is just a conditional statement. Basically, it's an if-else statement, but you just put it on the same line, and it works if it's just a simple assignment, right? If you're going to have a complicated thing where you're going to be like doing several operations here, a conditional expression is not the good thing. But if it's just basically just do a simple assignment, you know, assign this to this, but you first have to check this condition. This is what we do, okay? So you could even do like recursive functions. So a recursive function, basically we have the base case. So for factorial, we're going to say take the number and return you know, the function factorial on n minus 1, and keep going until you reach the base case, which is when n is equal to 0, return 1. And this works. We get factorial 5 here. And here we can kind of turn this entire factorial function into a single conditional expression, okay? You basically start off with return the base case for when you have the base case, and then otherwise return the recursive expression, okay? So this is probably, from a readability standpoint, this is probably harder than this, okay? But again, just because it is such a simple expression where you're basically just returning one thing here, it can be done, okay? Yeah, so the conditional expression is certainly more concise. Whether it's more readable is debatable, but basically, if you've got something simple, a conditional expression, I don't think takes away from the readability. Again, it should be simple though. Okay. We saw this earlier, but I guess we're revisiting it here. We saw star args for gathering and spreading out variable length arguments for a function, right? So we could do print all.star args, and you can give a tuple of a bunch of stuff, and then star args is going to kind of just spread it out into this iterable sequence and deconstruct it. And so we could take star args, and now we can iterate over this, basically the tuple of all of the values being thrown into it. So, you know, what do we have here? So here I've got roll star dice, and we're going to say for die and dice, okay? So, so here we're going to take, this is basically one 20-sided die, and we're asking what, so right now I've only given it one object, okay? So there's nothing to spread, so it's going to just, for die and dice, there's only one value, so it's going to just say for 20, okay, return a random integer from 1 to 20, and print that out and return the total. Okay, so here it's just what's the outcome of one 20-sided die? It's 12. Here I can give it, say you're going to roll 2 6-sided die and 1 20-sided die. Okay, so I have 6, 6, 20, and the outcomes were 3, 4, and then the 20-sided die rolled out to an 8, and so the sum is 15. 6, 6, 20, I get 1, 5, 2, I got 8. 6, 6, 20, and 20. By coincidence, I rolled 3s twice, an 8 once, and a 3 again. And so basically here we're just saying how many dice are we rolling. So here we're rolling a total of 4 dice. 2 of them are 6-sided, 2 of them are 20-sided dice, and that's what we're getting here. But basically, this allows us to kind of give it multiple length things, and we're just iterating over each of these objects that we're passing to it. Okay, and then you got double star quarks, star quarks, and basically this allows us to pass not just a tuple of values, but a dictionary of values. Okay, so here I'm going to pass pretty much a dictionary without the curly braces, but we're going to say CA equals California, OH equals Ohio, and all I'm doing is I'm doing key star S, or I'm sorry, I forgot to update this to use curly brace notation, but basically take that string, put it into the key, and then take the value and put it into this location here. So we're going to say key California has value California, key OH has value Ohio, and we're just iterating through the dictionary that would pass it. And if we wanted to take 2 lists and zip them together, we could do that, right? So we zip these 2 lists together, CAOH, Texas, Washington. We zip these names together. If I try to pass the dictionary directly, it fails. We have to use star on the dictionary to kind of scatter the contents, and that works just fine. Okay, star D. All right, and so this is quite handy if you have something like in Matplotlib, and I think I have an example of this in our Matplotlib slides. Matplotlib slides is you can kind of pass it a dictionary of optional settings where you say, I want the line type to be this, I want the color to be this, I want the line width to be this, kind of some settings that you want common for a bunch of graphs that you're producing, and you can just pass those optional arguments as star args or star quarks, and all of the plots that you create will have kind of the same settings being implemented there. Okay, we'll end just a few minutes early today. Let me give you your last view quiz answer, which is the letter B. B as in bear is your last view quiz answer. Okay, we'll end here, and have a good rest of your day. We'll see you guys on Friday. This week's going by quick already, huh?